In this video, we're going to do a few examples that involve using the sum and difference formulas. Okay, so remember, these are the formulas. So sine of alpha plus or minus beta is sine of alpha times cos of beta plus or minus cos of alpha times sine of beta. Cosine of alpha plus or minus beta is cosine alpha cosine beta minus plus, so change the sign, sine alpha cos beta. Tan of alpha plus or minus beta is tan of alpha plus or minus tan of beta divided by 1 minus plus tan of alpha tan of beta. Okay, so let's start with finding the exact value for sine of 7 pi by 12. Okay, so the first thing we want to notice, so we want to try and write 7 pi by 12 as angles that we know. Okay, so this is in radians. So I know that it's 4 pi by 12 plus 3 pi by 12. Okay, are those useful? Well, 4 pi by 12 is pi by 3, and 3 pi by 12 is pi by 4. So those are ones that I know. This is 60 degrees and 45 degrees. Okay, so those are ones that we know. So this is what we can use. So why did I break it down 4 and 3? Well, I know that none of my special angles have denominator 12. Okay, and 4 and 3 add to 7, but they're also multiples of 12. So I knew they would cancel with some parts of the 12. Okay, so that's how I figured that out. Okay, so that means that sine of 7 pi by 12 is going to be sine of pi by 3 plus pi by 4. Okay, so that is, so this is my alpha, okay, this is my beta, so it's going to be sine of alpha, so sine of pi by 3 times cos of beta, so that's pi by 4. And then for sine, you keep the sign the same, so I'm still going to have plus. And then I have sine of beta, so pi by 4, times cosine of alpha, which is pi by 3. Okay, so this, oops, I did it in the wrong color. Not that it really matters. So this sign and this sign match. Okay, now I know the exact values for all of these. Okay, so sine of pi by 3, that is root 3 over 2. Cosine of pi by 4 is root 2 over 2. Sine of pi by 4 is also root 2 over 2. And cosine of pi by 3 is 1/2. Okay, so I get root 3 root 2 over 4 plus root 2 over 4. So I could take out the root 2 over 4, and then I get root 3 plus 1. Okay, which is approximately 0.9659, which happens to be the same as what we found for cosine of 15 degrees. Okay, so which is not it's not weird. So the sine and cosine values are often different depending on the angle. So 15 degrees is pi by 12. Okay, so if I do 180 divided by 12, I get 15. Okay. So if I have 7 of those, this one is 105 degrees. So it happens to have the sine and cos switch there because of where they are on the unit circle. Okay, let's try this one over here now. So we want the exact value of cosine 40 degrees times cosine 10 degrees plus sine of 40 degrees, sine of 10 degrees. Okay, I don't know anything about 40 degrees or 10 degrees. Okay, so I don't really want to be computing these on their own because I don't know how with the exact value. Okay, I can do it on my calculator and get an approximate value, but I don't know exact value. But I do notice that this looks like, okay, so looks like the right-hand side of the formula for cosine alpha plus or minus beta. Okay, so that means it should be equal to the left-hand side. Okay, so I just want to figure out what that left-hand side is going to be. So we're actually going backwards. Okay, so if I go back up, so I want to remember that the signs switch for cosine. Okay, so it's cos of two different angles, and then sine of the same two different angles. So that's why I thought this one. And the signs switch. Okay, so my angles here, so I'm going to have alpha equals 40, beta equals 10, and the signs switch. Okay, so the sign that's here is going to be different than the sign inside. So it's going to be 40 and 10, and it's going to be the opposite sign. So it's going to be a minus instead. Okay, so this is cosine of 30 degrees. Now cosine of 30 degrees is a nice one that we know. Okay, so that's going to be root 3 over 2. Okay, so you can also go this direction. If they give you angles that you don't know, maybe they go together into an angle that you do know. Okay, let's try example 5 here. So we know cosine of theta is 1 over 4. And we know that theta is in quadrant 4. Okay, so we want the exact value of sine of theta minus pi by 6. Okay, so the first thing I'm going to do is think about this angle I'm actually trying to find, the sine value I'm actually trying to find. Okay, so this is a minus inside of the sine, so I can use the formula for this difference for sine. So this is going to be sine theta cos of pi by 6, same sign. Okay, so for sine, the minus that's in here is also a minus out here. And then it's going to be sine of pi by 6 times cos of theta. Okay, so some of these I know. So I don't know sine of theta. Okay, but cos of pi by 6 I know is root 3 over 2. Okay, sine of pi by 6 I know is 1/2. Okay, and cos of theta, they told me, is 1 over 4. So this, I guess I can write it, root 3 sine theta over 2 minus 1 over 8. Okay, so what I need to do is figure out what sine theta is. So I'm going to use the fact that cosine theta is 1 over 4 and make a triangle. So if that's theta, cosine is the adjacent over the hypotenuse. Okay, so I know that the adjacent side is 1, and so that makes this side is going to be the square root of 4 squared minus 1 squared. So that's the square root of 15. Okay, this is a right triangle. Okay, and that means that sine of theta is going to be root 15 over 4, but it's going to be a negative. Okay, now it's negative since theta is in quadrant 4. Okay, so remember in quadrant 4, so here's 1, 2, 3, and 4. So it's all students take calculus. So sine is positive in quadrants 1 and 2, negative in quadrants 3 and 4. Okay, so that's why this is going to be a negative. So now I can plug this in. So this is going to be root 3 over 2 times negative root 15 over 4 minus 1 over 8. Okay, so that is negative 3 times 15 is, so root 45 over 8 minus 1 over 8. Okay, so I can take out the minus 1 over 8. And root 45, 45 is divisible by 9. Okay, so that's going to be 3 root 5. And then I'm going to have a plus 1. Okay, so this is going to be my exact answer here. Okay, I'm just going to make a little comment. So root 45 is the root of 9 times 5. So that's root 9 times root 5. So that's why it's 3 root 5. Okay, just so you have that there. Okay, one last example here. So we want to establish this identity. Okay, now again, I'm going to choose the left. So there's not much to do on the right-hand side. Okay, so I'm going to choose the left-hand side to start with. Okay, so the left-hand side is sine of 3 pi by 2 plus theta. Okay, so using the sine formula for the addition, this is going to be sine 3 pi by 2 times cos theta plus sine theta cos 3 pi by 2. Okay, remember for the sine one, these are the same. Okay, now I know some of these. So we know sine of 3 pi by 2. So let me just draw a picture. Okay, 3 pi by 2 is one of the nice ones that we're supposed to know. Okay, so it is down here. Okay, so it's that angle. So it goes through the unit circle at the point 0, 1. So you want to remember that this is cos 3 pi by 2 is the x value, and negative 1, and sine 3 pi by 2 is the y value. Okay, so that means that the sine of 3 pi by 2 is negative 1. Okay, and the cosine of 3 pi by 2 is 0. Okay, so because it's 0, okay, this term is equal to 0. So I'm just left with negative, cosine theta. And that is my right-hand side. So now we've established the identity. Okay, this is the angle 3 pi by 2. So that's just a few examples using the sum and difference rule, mainly for sine and cosine. We didn't actually use the tan one, but it is there as well.